Hi everyone. Today I want to talk to you a little bit about modules 4.2 and 4.4. These are solving absolute value inequalities. We solved some absolute value equations yesterday. Okay, so let's see. Absolute value inequalities. Remember, inequalities are these symbols. And let's just guess. All right, I'm going to solve it. I'm going to pretend it's not an inequality. How's that? I'm going to solve this little equation. Absolute value of x equals 7. Alrighty, that means that x has to be either positive 7 or negative 7, right? Because 7, absolute value of 7 is 7, absolute value of negative 7 is, yeah, we get two solutions. And I'm going to put them on this number line because something tells me those are going to be really important. And then let's just play a little guessing game here. Let's go back to the original equation here, or inequality, I should say, and let's plug in some numbers. Okay, let's plug in a 0. Okay, 0 is right here on the number line. Let's see if that's a solution. Is the absolute value of 0 is 0, and 0, because it's 0 units from 0 on the number line, and 0 is less than 7. Oh, that's a solution. Cool. Alrighty, let's try 10. I'm way out here at 10. Absolute value of 10 is 10. Is 10 less than 7? Nope, not a solution. All right, let's try negative 10 down here. Absolute value of negative 10 is 10. Is 10 less than 7? We just said it's not, so that's not a solution either. What about 4? Let's try 4 somewhere in here. There we go, 4. Absolute value of 4 is 4, and 4 is less than 7. So, okay, this is a solution too. Let's try negative 2. Negative 2, somewhere in there, right? It's a terrible number line, but we're just kind of plugging numbers in to see where solutions are. Absolute value of negative 2 is 2, and 2 is less than 7. This is a solution too. Or also, let's try negative 5. Put negative 5 right about here. Have to write negative 5 up there. Alrighty, negative 5. Absolute value of negative 5 is 5, and 5 is less than 7. Boom, another solution. What about if we try negative 6? I shouldn't have done that. Another one really close. Alrighty, negative 6. Absolute value of negative 6 is 6, and 6 is less than 7. Alrighty, what if I go over here at positive 6? How about 6.99? Woo! You can't see that. 6.99. The absolute value of 6.99 is 6.99, and that is less than 7. Okay, folks, are you seeing that the solutions here are in between these two? Nothing we picked that was outside of there, or, outside of this region was a solution. And these were what they call critical points, when you pretend it's an equation. And we can see because it's less than, not equal to, these aren't actually solutions there. But this is what our solutions look like. Anything you plug in between negative 7 and 7 are going to make that true. All right, let's try the other one. If we pretend it's an equation and solve it, we're going to get the same solution, right? X, negative 7 and 7. But when we plug in some values, let's plug in a 0. That one worked over here, right? Okay, let's plug in a 0. Absolute value of 0 is 0. And is 0 bigger than 7? No way. All right, what was the next number we tried? A 10. Let's try a 10, way out here. Absolute value of 10 is 10, and 10 is bigger than 7. All right, that's a solution. What about 8? Absolute value of 8 is 8, and 8 is also bigger than 7. What about negative 8? Absolute value of negative 8 is also positive 8, and that is bigger than 7. What about negative 9? Absolute value of negative 9 is positive 9, and positive 9 is bigger than 7. Okay, so now it looks like, let's try another one in here. Let's try a 2. Absolute value of 2 is 2, and 2 is not bigger than 7. So this one kind of strangely looks like solutions would be on the outsides. any number you pick that's down here, a negative 10, absolute value positive 10 is bigger than 7. These are all going to be solutions, but anything you pick in between them is not. Now, what about these endpoints here, these solutions we got when it was an equation? If we plug in a 7, the absolute value of 7 is greater than or equal to 7, so we'll do hard circles there. And the same here because we have this equal sign. Here we did open circles because we don't. All right, so folks, I'm here to tell you that solutions will always, for these absolute value equations, these solutions will always be either be between, which I called inside, between these two numbers, or they'll be on the outsides. And the best thing is the answer is always, right? What does that mean for us? What that means for us is that we don't need this many test points. We can just pick one, and if it happens to be inside and it works, then the solutions must be inside. If it happens to be something on the outside, answer on the outside. Let's show you what I mean here. We're going to think of this as solving an equation, right? The very closely related equation. Just ignore the inequality. If we know that the absolute value of x equals 2, then we know that x has to equal negative 2 or 2. They both work when you plug them in. These will be the endpoints of our solutions, much like our negative 7 and 7 were up here. They were places where solutions either start or stop. Okay, so I'm going to put them on here. Negative 2. And instead of picking like a million points to try out like I did on the first example, we are just going to pick one test point. And I don't really care what it is. Let's try, why don't we just try x equals 1 just to kind of see how that goes for us. X equals 1. Alrighty, that's right here. Let's plug it in and see. I'm talking back to the original, the inequality. So I'm going to plug in a 1. Absolute value of 1 is 1. Is 1 less than 2? It sure is. This is a solution. We don't have to try any other things. If 1 is between negative 2 and 2, then all the other solutions will be between negative 2 and 2 also. Isn't that much faster? And to decide if we include the endpoints or not, we look at this. If there's an equal sign, we do. And you can try it out. If you plug in one of the endpoints, 2, absolute value of 2 is less than or equal to 2. It works out just fine. Not much nicer, one test point. All right, let's try a couple more here. I'm going to take a pause and fold some paper. Okay, before I do move on, we can write these answers in inequality notation. Two numbers sandwiched between each other, right? Or you could use this inequality notation, or we could use interval notation. Solutions start and include negative 2 and go to 2, just so you don't forget what those notations are. Okay, I think CK12 has your answers in interval notation. So we'll practice some of that. Okay, let's try, I have this one and then 2 more to practice and we'll be done. We'll try to keep it nice and easy for us today. Okay, so this one, give me a minute till this starts to focus. There we go. Alrighty, we are going to pretend this is an equation. We're just going to take this and say that's going to equal 6 instead of being inequality. We're going to remember our lesson from the other day where that means that whatever's in there either equals 6, so its absolute value is 6, or whatever's in there has to equal negative 6, so its absolute value would be 6. And we can figure out what numbers make that true. And that's going to give us our possible endpoints there, right? So I'm the endpoints of our solution. So I'm going to put those right on our graph. And we know from our practice with that awful one I did at the beginning with plugging in a million points, solutions are either in between or on the outsides. So let's pick just one test point. Pick a test point. Let's try, 0's easy, right? But let's try 1. I don't care what you plug in. You could try 2, you could try 100. It doesn't matter to me. I'm just going to try 1 because it's kind of easy. And I'm going to plug it back in here. Alrighty. So we get the absolute value of 2 times x, which now we're going to say 2 times 1, is greater than 6. All right, 2 times 1 is 2, and the absolute value of 2 is 2. Is 2 greater than 6? It's like, no way is 2 greater than 6. So this is not a solution. So what that tells us is because 2's in between these and it's not a solution, then there are no solutions in between. They're all going to be on the outsides. Now we'll have open circles on these endpoints of our solutions because we don't have an equal there. So in interval notation, this is going to look like solutions start and then end at -3, and they'll start again at 3 and never end. Okay, those are our solutions, both of those. And the CK12 uses this, which means union. That means both intervals have solutions. Both of them work. So I think when you see that, don't be freaked out. It just means it includes these. They throw in an upside down U to fool you. Just don't worry about that, right? Just look for this means both. So the right side up U. I would have your notes with you when you do your CK12 work. Okay, let's try 2 problems. Like I said, work at your own, pause me, work at your own pace, come back and checky check. All right. I'm going to pretend it's an equation to get the endpoints of solutions, and then I'll decide with a test point if solutions are between or on the outsides. All right, so I know that whatever this sums up to, if it's 11, the absolute value will be 11, and also if it's -11, its absolute value will be 11. And I'm going to take a minute to solve these problems, adding 1 to both sides, dividing by 2. Adding 1 to both sides, that's going to be -11 plus 1 is -10. And dividing by 2. Okay, so what I found was 2 endpoints. -5 and 6. And I'm just going to pick any number I want to plug in to this original equation. I'm going to plug in a 0 because that just seems like it should be really easy to plug in. So instead of 2x minus 1 is less than 11, that's our original equation, I'm going to do 2 times 0 minus 1. Okay, 2 times 0 is 0 minus 1. I'm getting -1. And the absolute value of -1 is 1. And 1, holy cow, 1 is less than 11. That's totally true, which means this is totally a solution. And because it's between -5 and 6, that's where all the solutions are going to be. Now it was a less than, so I'm going to put open circles here. So our interval notation, final answer, would be solutions start at -5 and go up to 6. And that's our interval notation final answer. All right, go ahead and pause me and try the next one. I'm going to solve this as an equation, understanding that if all that's in there sums up to 10, then the absolute value of 10 will be 10. And if all this in here turns out to be a -10, that absolute value is also 10. So I'll have 2 possible things that this goodness could sum to give us something whose absolute value is 10. I'm going to subtract 5 from both sides and divide both sides by 5. I'm going to subtract 5 from both sides, way down at -15, and divide both sides by 5. And that's going to give us the endpoints of our solutions. I don't know yet if they're in between -3 and 1 or on the outsides of -3 and 1, but I'm going to pick a test point and try it out. I'm going to try it out in the very original equation, the inequality actually. I'm going to plug in a 0. I like to plug in 0 because it's kind of easy. So 5 times 0 plus 5